welcome back to another basic coding on the C64. Now I'm sorry this one took so long to come out. This winter has been pretty harsh. I've been sick, I haven't been feeling good, I've been coughing my guts up, sniffles and all that, and I didn't really want to record a video with me coughing and spluttering and sniffles and all that in the background. It would just drive you nuts. Now I am still rather a bit sick, but it's under control. I'm not coughing all the time. I don't know the sniffles or anything like that. My head's a bit fuzzy and all this, of course, and yeah, I got to sleep earlier, but yeah. But anyway, that's enough about that. Let's get back onto the Commodore stuff, alright? So, let's see. Okay, cool. So now, you remember last time where we left off, we've got this balloon floating down. Going from top left, down to bottom right. No worries. And we'll just do this, and so we remember what the code was. Boop, there we go. Up and away. Clear the screen. Set a variable to the start of the VIC2 chip there. Turn on the second sprite. I lost my what I had before with the binary stuff, but hold on, put it here. So just so to jog your memory, where's me? Oh, got my tablet around the wrong way. Okay. Just remember, so we've got our binary stuff down here. I'll just bring that back down to 1. So what we got here is 4, which was, hold on, so back to this. So basically you see here, when we turn it on, as we remember from our registers over here, 21 is to turn them on and off. So basically at the start of the chip, there's a whole bunch of registers at the start, and whatever values are passing into them does the thing. Alright? Good. Okay. So I'll put my beautiful mug back up. Okay, so let's go back to the GIMP there. So over here, we've got our registers. Just doing a quick recap because it was a long time between episodes. So yep, position, extra movement, which we'll get to in a second. Turning sprites on and off, vertical scaling, priority, multicolor mode, horizontal scale, the multicolors and colors, and you can ignore this bit down here because I was actually wrong. So go away. So basically, all these set at the start of the chip, and away we go. So we'll go back to the C64 here. So we've got set ourselves up the start of the chip here, as it says here, start of the display chip. Then we turn it on, which is 4, which is the second sprite. Now remember, everything in this is actually 0 indexed. So everything starts at 0. So that's nothing. Okay. 0, 1, 2. Because 4 is there. So you're turning on the second one. Because 0, 1, 2. It's confusing as all hell. And yeah, it can be confusing as all fuck, actually. Working in binary can be annoying. But it saves a lot of memory, and it saves a lot of time and hassle when using these sort of flags. Okay. Next line was read to put set where the Sprite 2 data will be. What was that one? Hold on. I think that is what line is it? 41. Oh, hang on, no, that's later on. Oh, right. That's changing the color. Yep, that's right. This one's changing the color to putting it as 8, which is a brownish color. Load the sprite data into memory, which is that down there. Then start moving the sprite and repeat ourselves. And this is all the data in the sprites. So I'll bring back the GIMP in a second. Hold on. So my Foxy sprite, there we go. grid. There we go. Okay, so where's the GIMP? There's the GIMP. Okay, so remember here we had to do all our calculations. Add up all the dots inside each row, and we get our values over here. So hopefully that's okay for the recap. So basically, this is all the sprite data. This is what the sprite looks like. This is where it's been put in the memory. This is actually put in a memory. This is setting the sprite color and stuff. So this is basically we're doing pre-processing, setting up the sprite details, where it is, what color it is. I don't know. Does it drink from the bottom or the top? I don't know. So does it prefer cats? Stuff like that. So basically we set up all the principal properties of the sprite, load the data into Sprite, then moving it around. That's where the aspect of a sprite comes in, because it's already in memory. It stays in there. It's just a block of memory we can reference multiple times, or just move it around. Blah, 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 blah. But here's a real kicker. Sprite positions at this point with this, which is 255, that is absolute maximum that sprite, that position register can have, which is the fourth one, which is sprite 0, sprite 2. That's the X value, and that's the Y value. So basically it's gone from top to bottom, so 0 to 256. But that comes down to here. What about all this area? How do we put it over here? Well, that's what, if we go back to the GIMP for a tick, okay, this is what this extra move here is for. This handles the sprite going outside over 256. The sprite positioning. So let's have a look. Yeah, the book. Okay. So X and Y position work together to pinpoint your da. I'm not sure if I actually went through this in the last video. I don't know. But anyway, I'll repeat myself just to make certain of it. Okay, it does not. Once again, statement 30 uses the 4x. You may have noticed that the balloon does not move to the far right hand of the screen. Positioning in the horizontal direction is difficult since you need 320 locations, and you therefore need an additional bit, which will give you up to 512 positions. If you do not understand how we arrived at this figure, think of an extra bit being added to the left-hand side of a byte. This would be equivalent of 2 raised to the power of 8. The extra bits in all sprites are stored in the most significant bit register, MSB, register 16, okay, which we just saw when I just showed you the list of all the registers. Bits 0 to 7 of this register correspond to sprites 0 to 7 respectively. If you are not using positions greater than 255, the corresponding extra bit position must be turned off, i.e. must contain a variable 0. Here's how the SMB works. After you've moved the sprite to location 255, poke the sprite's decimal value into register 16. For example, to move sprite 6 to horizontal locations 256 through 230. Use this statement. Poke V plus 16, 64. Then use a for loop to move the sprite. To move sprite 6, the 64 spaces from Hang on. Okay, they just got this confused because we're using sprite 2, not sprite 6. But anyway. Okay. So basically what we've got to do is it goes from here down to here. So we've got to say we're going to use it, this sprite, this extra bit. Then we've got to go say, move it from here to here, then do another for loop to say, move the extra bits. Which is interesting. Okay, so let's update our thing here, which it says in the book. Sorry, if I'll go me for a tick. You see in the book, got a little bit of code here just to update it. Okay, not much to do. Okay, so go back to this, and I'll turn my beautiful, beautiful mug off. Okay. So, I am not putting in that data all again. Spoke. V plus 5, 100. Oh, okay, hold on. Okay. 10. Yep. 204, yes. Then we set it to that. Then we load it in. Okay, so this is a different one. 25. Okay, yep, 25 is a different one. V plus 5. 100. Okay, let's try this then. So what have we got? We got 25. 25. Poke. V plus 5. And 100. Whatever that does. Okay. V1664. Oh. Okay. Okay. Okay, V plus 5. 10. Okay. That's a bit wonky. So X to 255, yes, that's 30. 40, yep. Okay. I'm going to have to rewrite a couple of bits here. So 50 equals next. So overriding line 50 here with something else. Okay. And 60. Okay, 60. 60. V. Oh, hang on, 60. Poke. V plus 16. So basically we're saying with the additional bit for Sprite 2, then no, wrong line. .4. There we go. Oops, made a bit of a boo-boo. There we go. 16 and 4. So weird talking with these earbuds in my head. Makes me feel weird. Okay. 70. 70, 70. Okay, so 70 is different. So, okay, 70. 4 x equals 0 to 63. And then we, okay, so this line here says we're just about to use it, then just about to use some extra bits. So basically it turns it off, turns it on, then say we're going to use extra bits. So I'm not sure why we have to turn it on, then do things, instead of why don't we just turn it on at the top? I guess that memory issues, because it adds an additional byte to every thing, but yeah, okay, back in these days you had to be very frugal with the memory. 80 poke V plus 4, so setting the Y position, or X position is it? Yeah. Set an X position to be bigger than 255. Next. Oh, 90. Next. 100. Turn off the extra bit. I suppose it's a memory management thing, I guess. And turn it off entirely. There we go. 110. Go to 30. So this one's going to be a fairly big program. So if we go to list. Okay, so we've still got all our data, we've still got all this stuff, and it doesn't even fit on the goddamn page. So this one is fairly big. Not bad. So if we run this, it should, from what I can gather, since it's not using the y-axis in any way, shape or form, it just goes across. Okay, so if I run it, just goes. We can't. Oh, there it is. Whee, there you go. Boop, boop, and redraws itself. Boop, boop. A little bit blinky, but okay. That's cool. Right. Okay, so let's see what this book says right now after that. Okay, so we go escape, list. Okay, so we can see from here. Line 60 sets the most significant bit for Sprite 2, which is this one here, so I was right, it turns it on. So it adds that extra bit for x-axis location. Line 70 goes 970 through 90, contain the loop that moves the sprite, Sprite 2 across screen locations 256 to 320. Line 100 turns off the MSB, so the Sprite 2 can go back to the left edge of the screen. In other words, when the SSB is on, the sprite can only move from 256 to 320. Ah, okay, I see. So if we have it on, it can't move anywhere else outside that place. Okay, fair enough. Why, I don't know. Okay, you have to turn it off before you can move the sprite. Blah, blah, blah. Note that the program we used on turning on individual sprites can also be used to set a specific MSB. For a complementary statement which will turn off a specific bit is poke v plus 21, peak v plus 21, and 255 minus 2 to the power of Sn, which is the sprite number. Okay, fair enough. Okay, cool. Ow, my leg. Oof. So, that's how we move Sprite the extra bit. Extra little thing here. Okay, fair enough. This was the early 8-bit days. Okay, so, yeah, okay. So, moving on to the next bit. Expanded sprites. You can increase the size of each dot of the sprite so that the sprite is twice as wide, twice as deep, or expanded in both directions at once. There are two expand registers. Register 23 doubles the width of the sprite. Register 29 doubles the height of the sprite. The method of expanding sprites is the same that we used when enabling them. To expand a specific sprite in the x direction only, use the following statement. Poke v plus 28, comma, peak v plus 23, or 2 to the power of the sprite number, where Sn is the sprite number. The same applies when doubling the height of the sprite, except this time we use v plus 29. Okay, let's try this. Try adding the following line to your original program. Okay, so where can we put this? Let's say, put it in here, say 14. Let's put it at 14. Okay, so you can't really set the individual scale. It just doubles it. So if it's there, it's normal size. If it's not, it just doubles the size. It makes it bigger. Okay. Okay, so let's have a look. We've got a little bit of code here in the book, so let's try this out. So we're going to put it in the middle here, so we say 18. Oh, am I using it any further down? Doesn't look like it. Okay. So we go 14. Poke. V. Plus 23, which is the horizontal. Is it horizontal? No, first one is 23 is vertical scale. 23.4, so we're doubling the size of Sprite 2. Please remember all your binary flags. V plus 29, so the horizontal scaling. So we want to scale Sprite 2 really big. So if I go put that in, I'll list it. Let's see if it came out correctly. It did. The formatting is not correct, but I'm not really interested at this point. So if I run this, it should have a really big sprite. There we are. We do. We got a bigger sprite. It's a pity that I couldn't put in an actual scale in there, but you have to understand that these registers are internal memory on the chip. So the chip itself has its own internal memory, which is not overly great, I'd imagine. And these have to sit at the start of that. So if I was to say have horizontal scaling on this, like actually define a scaling, I would need to be another 15 bits, like 15 bytes actually, like with the position. So sprite position. So let's go back to our registers here. So up here we got 15 for the, or 16, sorry, for the position, for where the sprite position is. So basically you have two values, x and y, for each sprite, which is 8. And that's a byte each. So that's another 16 bytes added to the front of the chip. Now I don't think that the VIC chip could handle that even. I'm not sure if the memory in it could. But then again, this might not be internal chip memory, it might be system memory on the board. I'm not exactly sure how this works. But that is a lot more memory than needs to be. So that's another, what is that? Yeah, that's another 16 bytes. That's a lot of memory to be using up. Especially back in the Commodore days, especially in the 8-bit days, that was a lot of memory to work out. So even though it would be nice to have horizontal defined scaling and, you know, multiple levels rather than big or small. Okay, I did that the wrong way. So so basically it would be nice, but the chip just couldn't handle that amount of extra memory. It was just too much being used already. Because now we're going to be creating multiple sprites. So let's have a look. Okay, let's cancel you for a tick. Oh. Let's get up our memory again. So look how much is already in memory already. And we add another 16 bytes to that. That's a lot. So, yeah. Okay, creating more than one sprite. Oh, sorry. Put it back here. Yeah, so look at all this. Oh, it's not even fitting on the screen. That's a lot of data. Look at all this data here. Each number here is 1 byte. So that's a lot of memory. And once again, these machines only had 64 kilobytes of memory. And a lot of that is taken up by the system, by BASIC itself or system memory. If you're coding in assembly or C or something like that on this, you have a little bit more because you can unload a lot of stuff. There's one of the previous videos I did. There's a link in there for the great C64 talk, the ultimate Commodore 64 talk, which everyone should actually watch. it is really good and explains how a lot of things are actually done, and memory management is a very big part of that. So, let's get back to what we're doing. So, creating more than one sprite. It is a simple operation to create and store multiple sprites. Instructions on how to do this are given earlier in this chapter. To add Sprite 3 to your screen, include the following lines in the original Balloon program. Okay, so I think I might have stuffed up here for a tick. No, 13 was that one. Okay, cool. Okay, so let's see. Okay, so we go 11 poke v plus 21. Remember this, the 21st register is turning on sprites. But this time, instead of putting 4, we're putting 12. And because we want both Sprite 2 and Sprite 3. So I'll press enter here for it. Okay, so let's work that out, shall we? So we've got our binary over here. Sprite 12, how do you get 12? Well, you got 8 and 4. So we've got Sprite 2 and Sprite 3 activated now. There we go. So you see what I'm doing here with numbers, the decimal values, we're using as flags. So it's an interesting way of doing it. It's really cool, and sometimes in this basic you're not going to see it that much, but well, in Commodore Basic absolutely. But in C and C#, C++ and all that, you do see a lot of these binary flags. Like when I was coding for Blender, I saw this a lot. A lot of bit flags, they're called. Okay. So let's get back to our coding. Okay, 12. Poke 2042, comma 13. So now we're telling these two sprites to get the data from the same spot, like I said before. So data is already in memory, we're just putting it in different, we're just reading it twice. So we're not doubling our memory to duplicate a sprite. A sprite's still sitting in memory. We're just telling two sprites to look at the same spot. And because of that, each sprite can now move individually. Just, I have to admit, pretty cool. So 12, okay. So hang on, I'll give a good little drawing actually. I'm not sure if I explained myself right. So basically, over here, we've got here, I've got to change colour for it. So let's change to, say, that one. Okay. So basically, in memory, we've got dot, 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 dot. So we've got a system memory here. Let's say I got the sprite data here. All this. Which is basically the big data lines down the bottom. Now what can be, so what am I doing right now? So we've got Sprite 2 here and Sprite 3 here. Now they both have the same shape because they're both addressing the same spot in memory. So when they read their sprites, they're just reading the same bit. We're not duplicating ourselves into another memory bit over here. So we're not saying 3 point to this bit, not the existing bit. That saves a lot of memory, especially when you've got 8 sprites going and some of them use the same shape, just maybe different scaling. So what we could potentially do with this and say this one is times 2 scaling, but this one is times 1. This one we could have a different color on top of this and sit on top, so it looks like it's a multicolored balloon. So stuff like that, because it's both reading from the same spot. So if I change this, you'll change both of these. Understand? It's difficult to, it's really cool, that you can use the same memory in different containers. So imagine, like I said last time when I was explaining this, multiple boxes with the same content in them. Well, they're just linked to the same content. Anyway, enough of that. Oh, sorry. So let's go back to this. Okay. So that's basically what we've done here. We've told Sprite 2, which is that one, and Sprite 3 to go to look at location 13. Block 13 in the Sprite memory. Okay, so let's get on moving. So 34 x equals 1 to 190. Okay. For x equals 1 to 190. Okay. 45 poke v plus 6 x. Okay. So that means that we are setting the sprite x location of the sprite 3, which is 6, which is 6 number along. So just to recap, sorry, I know you don't like all this stuff, but anyway, sorry. So basically we got in Sprite, we've got a Sprite location, which is basically a bunch grid, like So Sprite 1 x location, oh sorry, Sprite 0 x location, Sprite 0 y location, Sprite 1 x location, Sprite 1 y location, which is in these registers here, these 16 registers here. So 2 times 8 equals 16. The x and y. And so we've got 2x and 2y. So start at the start of the chip and work our way forward. We'll just say like this. So that plus one of these. And we put the data in there and we get our thing. So sets x and y for that. So it's 0, 1, 2, 3, 4, 5, and 6 and 7. Understand? I'm not sure if I can make it much clearer. But anyway, so we're setting the x location for Sprite 3 to be like normal. Okay? 55. Poke v plus 7. So set in the y location, 190 minus x. So basically it's going to go backwards that way, which is nice. So let's kind of list this out just to make sure we're not stepping on each other's toes here. Doesn't really matter because I can't see jack shit. So basically that's going to set the x coordinates for Sprite 2 and the y coordinates for Sprite 3. X coordinates for Sprite 3, sorry. Then we're going to set the the y coordinates for Sprite 3, and that's the y coordinates of Sprite 2. Getting complicated, this program. So let's run it, and we should get 2 sprites running on screen. That one's going that way. Whoop! Illegally quantity error in line 55. Okay, what did I do? 55. Oh, hang on. No, that's setting the I think at this task may include the following lines in the original Plum program. So we've changed things so much that I'm gonna have to rewrite this, I think. Unless I remove line 55, line 70 and line 80. So remove line 70, remove line 80. So 70 rem removed, line 80 rem removed. Line 60 will have to go. Rem removed. So let's list this again, sorry. And line 50 is going to have to go. Yep, line 50 is going to have to go. So rem, oops, 50 rem. Rem remove. 100 I'll have to go to. Not really, but okay, so let's list and let's just make doubly absolutely sure of this. So so we're setting the y coordinate here of the first one, which is fine. We're in of sprite 2, so yeah, x equals that. Line 90 should say next. So 90 next x. So let's make doubly absolutely certain of this. Line x. Okay, so next x. Right. Cool. So if we run this, this should work now. There we go. Look at that. This one's going across, this one's going up, this one's really big, that one's really small. That is really cool. So we've got multiple sprites going. And that one's pink for some reason. Why is it pink? Okay. So let's see what the book says about this, okay? So, while it's way over there, okay. List, okay. I'm not going to be able to see this, but anyway. Yeah, line 11 turns on sprites 2 and 3 by poking their combined decimal values 4 and 8 into a sprite enable register. Line 12 tells the computer to find the data for sprites in block 256 of the VIC2 chip memory. Recall that 242 is sprite 2's pointer and 243 is the pointer for sprite 3. Lines 45 and 55 move the sprite around the screen by changing the values of x and y registers of that sprite. When you run the program, you can see 2 balloons moving around the screen. This is because we poked the same address into both sprite pointers when the phone. The following lines put sprite 4 on the screen as well. Let's try this. Let's put another sprite on screen, shall we? So 11 poke v plus 21. Once again, 21 is the turning on of the red of sprites. So 28, I don't need to go over this again, is the combined decimal places of 4, 8, and 16. Because 4, 8, and 16 are the third, fourth, and sixth number there. So, okay, 12 poke 2042 into 13, find that, oops, poke 2043, so sprite 3, get it from this location, this chunk. Poke 2044. Why does that number seem so goddamn familiar? 13. So it's looking at the same spot. 20, okay, 25. Poke. V plus. Now V is the start of the Vic chip in this case. Just in case you're wondering. Sorry, I'm not really explaining myself very well, am I? I hope you are all liking these videos, which, judging by the analytics, they are. These are some of the most, I don't know, most popular. Hang on, what are we doing on this one? What's 23 and 20? Oh, we're scaling. Oh, we're scaling Sprite 4, so it's going to be big. Oh, okay, cool. Anyway, yeah, judging by the analytics on YouTube, these videos, including my Leap Motion video, are some of the most popular videos I've ever had. Like, some of these videos that get like 30, 40 views in the first day, overnight, and none of my videos ever got that. So thank you all. I'm going to take this time to say thank you all for watching my videos. I'm really happy, and I really hope you will learn something and willing to give this a shot yourself. I even heard some people saying, oh, I might actually consider getting a Commodore soon. So, and I screwed this up. 48 is a little gravestone. So 48 poke. Got to remember not to use shift on everything. Okay, V8. Because remember, it's all in caps. So yeah, that's that. Okay. 58 poke V plus 9 100. Oh no, I didn't mean to do that. 58 poke V plus 9 100. Now if I list all this up, just to make sure that everything went in alright. I wish that sprite would move. But anyway. So yep. Okay, so setting the size of Sprite 4. Then Sprite 4, which is this one, is going to be moving from left to right. It's going to be on the same scale as the first one. So it's going to be on top. Alright, so let's go run. Just run it. No, it's... Okay, no, the other one's that's just sitting behind it. Okay, cool. So now we've got 3 sprites going. That is really cool. Oh, hang on, line 25 increases the size of sprites 2 and 3. My bad. I was got a bit confused there. Oh, okay, yep. Oh, yeah, Sprite 12. Oh, yeah, number 12. Oh, Jesus Christ. So, hold on. I'll escape. Hold on, just to explain this. List. Okay. So, there's line 25 here. This 12 for 23 is the combined decimal value of 4 and 8, which is the third number and the fourth number. Okay, that's what that was. Okay, so basically we're just, now we've got, I'm going to run this again because this looks pretty. Whoop. Yeah, no, wrong window. Hold on. There we go. Run. There we go. We've got some more sprites going. Yay. So what do we got next? What's the next? I think this is the last. Yep, this is the last bit. Now, Sprite Priority is saying which sprite is on top of the other. Is on top of what? Okay, so Sprite Priorities. If you are using more than one sprite, you may wish to make sprites cross over each other on the screen. Sprite to sprite priority is preset. Sprites having the lowest numbers have the highest priority, i.e. Sprite 0 has the highest priority, then Sprite 1, Sprite 2, etc. Sprite 7 has the lowest priority. Sprites with higher priorities appear in front of sprites with lower priorities. Sprite to background priority is controlled by the Sprite background priority register, which is register 27. Bits 0 to 7 in this register correspond to sprites 0 to 7. These bits are normally set to off, equal to 0, which means that the sprites have a higher priority than the background, i.e. they pass over any data on the screen. If you switch this priority for any sprite, you may turn on the relevant bit. For example, this statement makes Sprite 3 appear behind characters on the screen. Alright, let's have a look. So if I go this, so list, let's find a spot where we can put this. I think, I haven't done a 15 yet? I think I might have done a 15. No, I haven't done a 15 yet, I don't think. No, I haven't done a 15, so let's put this line in at 15. So, 15, poke, v plus 27. So I'm going to say sprite, which is the third sprite, my bad, to be behind the thing, which is, I believe, this one. So hang on, I don't think I need to. I need to do it this way. Go poke v plus 27 8. Now we should see that one disappear behind the screen. See, look, it's now behind the text. Haha! So I don't need to run that as a program. It's just put it in, pops it in memory, reruns it, rereads its memory. There we are. So now that's behind the text. Okay, so that's now a background priority. So you can have sprites flying around the background while your text is scrolling. Sweet. So that's it for chapter 7, Sprites. What was it, Advanced Sprites or Introduction to Sprites? Well, that's color graphics. Been there, done that. Made a ball bounce around the screen. Picks and pokes, screen memory map. Ball bouncing balls, no. It was just Introduction to Sprites. So, go back to me. So, we just finished that. Introduction to Sprites. Sorry it took 2 videos to do, but there was a lot of explaining I needed to do about bits and bytes and how registers work and all that. But the next chapter is a really cool one. We are going to be interfacing with the legendary SID chip. Gotta love me SID tunes. So we've got a big program here, so like this one here. So basically, what is this? Making sound and music. So basically, reading the contents. Okay, the SID chip, sample sound program, playing a song on your 64, creating sound effects, filtering, and music composer. Your Commodore 64 computer is equipped with one of the most sophisticated electronic synthesizers available on any computer. This chapter is an introduction to your computer's sound chip, the SID chip. The main features of the SID chip provides are volume control, multiple voices, waveform, frequency, and envelope generator. So, SID main sound interface device. Now the SID chip is absolutely legendary because it is quite literally a synthesizer. It is basically a 3-voice synthesizer, 4 if you're clever. Now it has sampling and all this. There's a great playlist on YouTube of all these great SID tunes, but you're showing the actual FM radio, the FM waveforms, sorry. So basically showing the waveforms what this chip is doing, which means it was a lot more advanced than the NES or any sound chip at that point. Only outclassed by the Yamaha, which came later on. Yamaha's synth chip. later on, which is really cool. So many great things you see, like sawtooth, that sort of stuff. So we're going to have a lot of cool fun in the next one. But that, like I said before, is for another day. So hopefully, it's like this. You have liked all this, and I'm going to put this in here. Go poke. There's a 15 poke v poke v plus 27,8. Now if I run that, should be fine. Okay, cool. So I'm going to let these go. Alright, so that's enough for now. Hopefully you enjoyed it. We learned a little bit more about sprites and moving things about on screen. A little bit more about memory and stuff like that. And hopefully, I really want people to actually go out and actually try this. Try coding these things. I did link the manual in my first video. I may as well link it again in this one, just so you can read up on the manual itself if you want. There's an online PDF of it. So, yeah. Hopefully you all enjoyed it. I'll see you all in the next video, where we're making sounds. Hopefully I will be doing more technology-based videos. I'm not sure the game videos are really good anymore, because, you know, it's a flooded market and all that, and like they get barely any views. So these ones have been getting a lot of views actually. So and a lot of people have been commenting on them, and I enjoy that. So for the third time, thank you very much for watching. You know, like, subscribe, you know, all that nonsense, and share. Please share. Absolutely. I don't care. I'm not a copyright zealot or anything like that. Go ahead. And I will see you all next time. Oh, and keep your comments up. Keep the comments going. I do enjoy them. If you find any errors or anything that I've said that is wrong, don't hesitate to correct me. That's fine. Like I said, I'm just reading through this manual, and we've seen a couple of times this manual actually being wrong. So, please correct me if you find any issues, and I'll see you all next time. Bye-bye.